Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to solve some examples problem on integration. Let's get started with the first example. So here is our first example. Evaluate the definite integrals. So here we have the definite integrals a, b, c, d using the properties of the definite integral and the fact that is given here. So integration of the function f of x with respect to x from -2 up to 3 is given as -6. Integration of the function f of x with respect to x from 3 to 6 is 10. And the integration of function g of x with respect to x from 3 to 6 is 2. So in that case, we need to evaluate all these. So let's begin with the first one, a. So in A, we are asked to evaluate this definite integral from -2 up to 3 of 10 times f of x. So 10 is a constant multiple. So basically, we can take that 10 out and then integration from -2 up to 3 of that function with respect to x. So that will be equal to 10 times integration from -2 up to 3 of the function is equal to -2 up to 3 of that function is equal to -6. So it becomes 10 times -6. 10 times -6, which is equal to -60. So the value of the integral given in part A is equal to 60. Okay, we get that. That is A. Now let's look at B. Maybe B involve a little bit more math. So in B, what we are asked to do is we are asked to find the integration from -2 up to 6. So here we have -2 up to 3 and then 3 up to 6. But here we are directly going from -2 up to 6. That means you can split this into two integrals. So -2 up to 6 is same as integration from -2 up to 3 first. Okay. And then from 3 up to 6. And then from 3 up to 6. You can do that. Because we are asked to integrate from -2 up to 6, you can integrate from 2 up to -2 up to 6 is there. So we can go from -2 up to 3 and then from 3 to 6. And this integral is given. This one, -2 up to 3 of that function is -6. So this will be -6. And then this one, 3 up to 6 of the function is 10. So plus 10. And if we simplify that, that is equal to 4. So the value of the integral given in part B is equal to 4. Okay. So we got the value for part A and part B using the property. Now let's look at C. So in C, we need to find the value of the integral from 3 up to 6 of f of x minus g of x. That means it is integration from 3 to 6 of the first function f of x with respect to x minus integration from 3 to 6 of the second function g of x with respect to x. We can do it like that. We can separate it. So we can integrate f of x, subtract, and then integrate g of x. Integration of the function f from 3 to 6 is a 10. So that is 10. So we can write 10 for that, which is equal to 10, and then minus integration from 3 to 6 of g of x. Integration from 3 to 6 of g of x is a 2. So that becomes 10 minus 2 or 8. So the value of the integral given in part C will be 8. Okay, finally, let's work on part D. Okay, in part D, we have to find the value of the integral, which is given as a sum. So it will be the integration of first plus the integration of second. But in the first, there is a 5, which is a constant multiple. You can write it outside. So that is like 5 times integration from 3 to 6 of the function f of x dx plus the second one is 6 times integration from 3 to 6 of the function g of x with respect to x, which is equal to 5 multiplied to 3 up to 6. If you integrate f of x with respect to x from 3 up to 6, you have a 10. So 5 times 10. So we can write that as 5 multiplied to 10. And then plus 6 times this integral, which is given up here, is a 2. 6 times 2. So we get 5 times 10, 50, plus 6 times 2, 12, which is equal to 62. So the value of the integral given in part D is equal to 62. So that's how we can use the property of the definite integral to evaluate the integrals like this, a, b, c, d, when the value of integrals on certain interval is given. Okay, let's move on to next example. So in this example, the graph of the function is given. Okay, graph of the function is given. Evaluate the definite integral using the graph of the function, which is given here. Remember, definite integral is equal to the area. So the first part is we have to integrate from 0 up to 3. 0 up to 3 of the function. So if I want to go from 0 up to 3, 0, 1, 2, 3, I want to go up to there. So if I want to go up to 3, the value of the integral is equal to the area of this triangle, is equal to area of that triangle. And you know that the area of triangle is base times height divided by 2. So if you look at the length of the base, okay, if you look at the length of the base, that is a 3. Okay, length of the base is 3, base times the height. If we want to look at the height, it is 1, 2, 3, 4, 5. Height is 5. You have to divide that by 2. 3 times 5 is 15 divided by 2, which is equal to 7.5. So the value of the first definite integral using the diagram given here is 7.5. Okay, that is the first one. Now let's move on to the second one. Okay, if you look at the second one, we have to integrate from 3 up to 7. So we are basically integrating from here, from 3 all the way up to 7. So this is 4, 5, 6, 7. We are going up to 7 like that. So you can clearly see that this integral is equal to the area of triangle, which is this one. Okay, the one I've stated here, which is above the x-axis, and the other one, which is here below the x-axis. So it is the sum of this area plus this one. So this value here is a 5. As you can see, this is 5. That is 7. Okay, so what do? We need to find the sum of those two areas. So area of this triangle above the x-axis is base times height divided by 2. Base here is from here to here. So if we want to measure this, this is 2 units long. Base times the height. This one is 5 units tall. Base times height divided by 2. Then plus, for this triangle, the base is from 5 up to 7 means 2 unit. 2 unit multiplied 2. If you want to see how tall is this triangle, it's also 5 units, but 5 units below the x-axis. So that is a negative 5. Negative 5, then divided by 2. So this one is 2 times 5 is 10, divided by 2 is a 5. And the next one is plus, and this one will be 2 times negative 5 is negative 10, divided by 2 is a negative 5, which is equal to 0. So the value of the second definite integral is 0. This integral is equal to 0, and we use the area of triangle formula. Remember, probably you have noticed that if the integral is above the, if we are evaluating the integral above the x-axis, the value of the integral is positive. If you are doing it below the x-axis, it will be negative. The reason is, if you look here, the value of the function or the height is positive when it is above the x-axis, whereas if the area is below the x-axis, that height or the value of the function is negative, that makes the area above and below with the opposite sign. In this case, these two triangles are congruent. They have the same area. Okay, they have equal area, but opposite in direction. So they cancel each other and we get a 0 there. Okay, that is the second part, part B. Now let's look at the third part, C, and find out what we have. Now in C, we have to find the area from 0 up to 9. Okay, 0 is here, and we have to go all the way up to 9. 0 up to 9, this point here is a 5. That is a 5. And we are going all the way up to 9 here. We are going up to 9. Okay, that is a 9. So what we can do is this one above the x-axis is a triangle. We can find that area easily. If I want to find that area, it is base times height divided by 2. So that will be equal to base. You can look here, this is 5 units long. So base is 5 times the height. Height of this triangle is also 5 divided by 2. But if you look at this picture below, this can be divided into two parts again. I can do this. I can make it a triangle there. Okay, that triangle. And then plus this rectangle here. Okay, triangle plus that rectangle. So the total area from 0 up to 9, or the value of the definite integral from 0 up to 9, is this area of the triangle above the x-axis, plus the area of this triangle below the x-axis, which is from 5 up to 7. So if I want to find that area, the base is 2. So I'm adding that 2 times the height. Height is 5 below, means negative 5. Okay, divided by 2. And then this rectangle, we have to add that. And area of that rectangle is base times height. Base is 2 units long. And then the height is again 5 units below the x-axis. Like that. So what we get is this one is 5 times 525 divided by 2 is 12.5. 12.5. And then this one is 2 times negative 5 is a negative 10 divided by 2 is a negative 5. So minus 5. And this one is 2 times negative 5 or negative 10, which is equal to 12.5 minus negative 5 and negative 10 is negative 15. So what we get is 12.5 minus 15 is negative 2.5 is equal to negative 2.5. So that is the value of the definite integral from 0 up to 9 of the given function whose graph is here. So always remember, if you are using graph to find the area, graph to find the definite integral, all you need to do is you have to calculate the area and add them together. But remember, if the function or the area is above the x-axis, the area will be positive. If it is below the x-axis, the area will be negative. You must consider the sign of the area while calculating the definite integral. Okay, now time for next example. Here is the example. They have given the graph. Below is the graph of y equal to x squared plus 5. This one is the graph of y equal to x squared plus 5. The area bounded by y equal to x squared plus 5, this one, x squared plus 5, and the x-axis is down here between or from x equal to 0 up to x equal to 5. How much is that area? We need to find that area. So we need to find this area if I want to say it and show it. Okay, this is the area I need to find. And you know that the area, this area, we cannot find it using any geometric formula because the shaded region is not a regular geometric shape. So what we do is, in order to find this area, we can use the definite integral. So that area is same as integration from 0 up to 5. Okay, lower x value up to upper x value, 0 up to 5 of this function, which is x squared plus 5 x squared plus 5 with respect to x. Okay, then what we do is we integrate this first. Integration of x squared, if you use the power rule, is x cubed over 3. Then plus the integration of 5 with respect to x is 5x. And then we have to evaluate this between 0 and 5 using the fundamental theorem of calculus. The meaning of that is we plug in the upper limit into this one, and then we subtract and plug in this lower limit. So if you plug in upper limit, it will be 5 cubed, which is 125. 125 over 3 plus 5 times 5, we are plugging in upper limit, which is 25. Then we subtract and plug in lower limit. If you plug in 0, that will be 0 cubed, which is 0 over 3, plus 5 times 0, that is 0. So basically, everything in the second parenthesis will be 0. And in the first one, 125 over 3 is 41 and 2/3. Okay, 125 over 3 is 41 and 2/3, and then plus 25. Plus 25. Which is equal to 41 and 2/3 plus 25 is 66 and 2/3. 66 and 2/3 as a fraction. If you want to write it as a decimal, it will be 66.666. It will continue. Let me round it to 4. So we can write 66.6667. So you can see that in order to find the area, we use the definite integral 66.6667. So definite integral always gives the area under the curve. Okay, area under the curve, which is bounded by x-axis below, and then the limit of integration on the left and right. And remember, in order to evaluate this definite integral, we use the fundamental theorem of calculus. Okay, time for next example, example 4. So here is that. We have to integrate this function, okay, from -1 up to 1. So what I'm going to do is I'm going to write the even powers together and odd powers together and separate that, meaning I'm trying to use the properties of integral to simplify this. So -1 up to 1, 6x raised to 4 plus 3x squared. Then minus integration from -1 up to 1, 7x cubed dx. I wrote this odd part here and this even part here. So this function is an odd function. And when you evaluate or when you integrate odd function from -a up to a, so here -1 up to 1, by symmetry, this area will be 0. So I don't need to evaluate that part. Even if you evaluate, the whole area or the value of the definite integral will be 0. I'm using the property. Now, the other thing is, this integral here is an even function. So for the even function, if you are evaluating the even function from -1 up to 1, there is a theorem. If we are integrating the even function from -a up to a, it will be double the area from 0 up to a. So in this case, 0 up to 1 of 6x to the 4 plus 3x squared dx. So instead of integrating from -1 to 1, you can integrate from 0 through 1 and multiply it by 2. That is by the property of the even function. So now let's try to integrate that. 2 is a constant, so we can keep that 2 outside. And then we have 6. And when you integrate this, you increase the power by 1. So 6x to the 5 and divide by the new power, and plus 3 is a constant, increase the power by 1, divide by the new power, and evaluate between 0 and 1. Here, this 3 and 3 cancel. Now we can evaluate this using the fundamental theorem of calculus. That is, you plug in the upper limit, subtract and plug in lower limit. So if you plug in 1 into this function, this is equal to 2 times 6 multiplied to 1 to the 5, that's a 6 over 5, plus 1 cubed, that's 1. And then minus, you plug in the lower limit, so you have a 6/5, and then 0 to the 5 is a 0. Then plus, we have a 0 cubed, that is also 0. So meaning of that is everything in the second parenthesis will be 0. So what I'm getting is 2 times 6/5 plus 1 is 11/5. 11/5. So 2 times 11/5 is 22/5. So that is the value of the definite integral. And remember, in order to evaluate the definite integral here, because it involves the even and odd function integrated from -1 up to 1, we use the property of the, you know, uh, definite integral for the even and odd functions, and we evaluate that. You could have done it by, evaluating the definite integral. You can first integrate everything and then plug in the upper limit and lower limit. You should get the same result. But sometimes, reducing at least one term like that will make our work much easier. Okay. Time for next example. Let's evaluate this. Evaluate the definite integral. So here we want to evaluate this from 1 up to 9 of 7 over square root of x dx. What I'm going to do is I am going to rewrite this a little bit. So this is how I am thinking of rewriting it. This is equal to integration from 1 up to 9, 1 over 2 root x dx. And then what I'm going to do is I'm going to write a 14 here. So if you analyze this carefully, see, 14 times 1 is 14. 14 divided by 2 is a 7. So I'm writing the same thing, but little differently. And what I'm writing here inside is 1 over 2 root x. This is easy for me to integrate because 14 is a constant I can write as it is. And the integration of 1 over 2 root x is square root of x. The reason is the derivative of square root of x is 1 over 2 root x. So the integration of 1 over 2 root x will be square root of x. Now we just need to evaluate this between 1 and 9 using the fundamental theorem of calculus. So if you plug in, that means you plug in the upper limit, 14 times the square root of 9 minus, and plug in the lower limit, 14 times the square root of 1, which is equal to, you can see in both of them there is a 14. I can factor that out. Square root of 3 is 9. Square root of 9 is 3. And then minus square root of 1 is a 1, which is equal to 28. Because 3 minus 1 is a 2. And 2 times 14 is a 28. So the value of the definite integral, which is given here, is 28. And we evaluate this using the fundamental theorem of calculus. And in order to integrate the actual process of integration, we use the reverse technique of integration because we know that the derivative of the square root of x is 1 over 2 root x. So the integration of 1 over 2 root x is the square root of x. Remember, the derivative and integrals are the opposite procedures. Okay, time for next one. Evaluate the definite integral 0 up to pi over 3 of 12 times sine x dx using first part 1 of the fundamental theorem of calculus. So we have already been using this fundamental theorem of calculus. If you are integrating from a through b of f of x dx, so when you integrate this, you get some function uppercase f of x. Say, for example, when you integrate the lower f of x, you get a new function f of x, which we need to evaluate between a and b, which is equal to, by the first part of the fundamental theorem of calculus, you plug in the upper limit, subtract and plug in the lower limit. That is the first part of the fundamental theorem of calculus. So that is what we are asked to use here. And we have already been using this, which we already know. This is the first part of the fundamental theorem of calculus. Okay, let's see. So here we have 0 up to pi over 3 of 12 sine x dx, which is equal to 12 is a constant. You can write as it is. And then the integration of sine x is negative cosine x. Negative cosine x. Because the derivative of cosine is negative sine. So integration of sine will be negative cosine, which needs to be evaluated between 0 and pi over 3. which needs to be evaluated between 0 and pi over 3, as I have written here. Now, all I need to do is plug in the upper limit, subtract and plug in the lower limit. So this one is negative 12 cosine x, because if we multiply that, that will be negative. So we can write that as negative 12 cosine pi over 3. Subtract and plug in lower limit. Subtract, and then because this is negative 12 cosine, plug in the lower limit, 0. Okay, now let's see what we get. So we have negative 12 there, negative 12, and then cosine pi over 3 is a half. Cosine pi over 3 is a half. Then minus, okay, minus and minus, that means plus 12, and then cosine 0 is 1. Cosine 0 is 1. So what we get is, here we get half of negative 12, which is negative 6, plus 12 times 1 is 12. So negative 6 plus 12 is a positive 6. So the value of the definite integral there is positive 6. And we evaluated this using the first part of the fundamental theorem. This one here is the first part of the fundamental theorem of calculus. Okay. Now let's move on to next example, example 7. So here we are asked to calculate the derivative. Look at this one, d over dx, derivative of the integral from negative 1 up to x of this one using part 2 of the fundamental theorem of calculus. Okay, what is part 2 of the fundamental theorem of calculus? It is like this. Part 2 of the fundamental theorem of calculus help you to find the derivative with respect to x of the integral function from a up to x. Note here, we are finding the derivative with respect to x, and we are going from a up to x. Okay, a up to x, but here the function will be f of t dt, some other function, right? F of t dt. If we evaluate this, this is equal to, because over here, this number can be any finite number, but here we have x, then it will be the function of x. It will be the function of x. So that is the second part of the fundamental theorem of calculus. But remember, if this one, in place of x, if there is some other function, we have to multiply by the derivative of that function also. So let's see what is the meaning of that. So here we have, let's see. Here we have derivative with respect to x from negative 1 up to x of 4t cubed minus t raised to 33 dt. Now, what this will be is, because this one, this value is just x, and then this is the function of t, our result will be just the function of t. That means wherever, just the function of x. So wherever there is t, we plug in x. So this result will be equal to 4x cubed minus x. So over here, it will be 4x cubed minus x raised to 33. That's it. That is the value of this, the derivative. That's the value of this derivative of the integral function from negative 1 up to x. You can see that negative 1 is a constant, just like a. And up here we have x, and we are differentiating with respect to x. So you just plug in x here. That's it. That's the simple case. But let's look at a little different case where the function on the top is different from x. Let's see how we can use the chain rule to simplify that. Okay, here it comes. So if we look at this one, what we are asked to do is we are asked to find the derivative, right? Calculate the derivative d over dx, that's the derivative from x to the 6 up to e raised to 5x of natural log t dt, okay, using the second part of the fundamental theorem of calculus. So if you remember the second part of the fundamental theorem of calculus, that was this. That is the equation. And what we need is, we need the lower limit of integral should be a finite value. But here both are the function of x. So what we need to do is we need to rewrite this a lot. So what I'm going to do is between x to the 6 and e to the 5x, I want to consider a number a between them. So what I mean by that is I want to say this. Suppose between x to the 6 and e to the 5x, okay, between x to the 6 and e to the 5x, there is a. So what we can do is this can be derivative with respect to x, derivative with respect to x of that integral from x to the 6 up to e to the 5x of natural log t dt can be written as d over dx derivative from x to the 6 up to a of natural log t dt. Using the property of integral, we can integrate from x to the 6 up to a, and then from a up to e to the 5, then plus the derivative with respect to x of the integral function from a up to e to the 5x of the same function, natural log t dt. So we use the property and we split into two parts. Now the second integral is easy to evaluate because it has a as the lower limit. But in this one, a is the upper limit. What we can do is we can basically switch this. It is easy. You can see here, we can switch this d over dx from a up to x to the 6 natural log t dt. But if we switch the limit of integration, the value, the total value will be negative of that. Negative of what we have here, opposite of that. So we put a minus and then plus d over dt integration from a up to e to the 5x natural log t dt. Now, we can keep that negative sign as it is, this negative sign as it is. Okay, we can keep that negative sign as it is. Now, because this upper value here is x to the 6, if it is x, we just plug in x. If it is x to the 6, we plug in x to the 6 there. So it will be natural log of x to the 6. And then, because this is not x, it is x to the 6, we have to multiply by the derivative, the chain rule. Because we are doing the derivative means we have to multiply by the derivative of that inside function. That will be 6x to the 5. Multiply that by 6 x to the 5. Then plus the second one, you do the same thing. So over here, in place of t, we plug in e to the 5x. So it becomes natural log of e to the 5x and multiply by the derivative of e to the 5x, which is equal to 5 e to the 5x, because the derivative of e to the 5x is 5 e to the 5x. Now I can write this one in front. So I can write that as negative 6x times natural log of x to the 6, and then plus, see, this one is natural log of e to the 5x. So these are the inverse function. Natural log and exponent function are inverse function. They undo each other, and we are just left with 5x. So that is 5x times 5 times e to the 5x. So we can simplify a little bit in the second term. 6x times natural log of x to the 6. Then 5 times 5 is 25x. Okay, plus 25x times e to the 5x. So that will be the value of the derivative of integral function, right? We are finding d over dx. This is what I'm saying. The derivative of the integral function, which is given here, is this one. So what I did here is we use the second part of the fundamental theorem of calculus. But when you look at the original function, it does not match with the theorem, meaning we don't have a constant a. So we introduce a constant between the upper and lower limit, and then we write the integral as two integrals here. But by doing that, we see that that constant is on the top. So we flip that, or we interchange the limit of integration. By doing that, the first integrals become negative. First integral becomes negative. And once we rewrite like that, we are able to use the second part of the fundamental theorem. But the problem here is the lower values are constant, as said in the theorem, but the upper values are the function of x. So what we do is, after we use the theorem, we also multiply by the derivative of those upper values. That is because of the chain rule, because whenever you are finding d over dx, the derivative, you must apply the chain rule. Okay, that is our 8th example where we use the second part of the fundamental theorem of calculus. Let's move on to example 9. So in this one, we use the first part of the fundamental theorem of calculus, right? This would be the first part of the fundamental using the part 1 of the fundamental theorem of calculus. Okay, here we want to use the second part of the fundamental theorem of calculus and then evaluate that definite integral. So our definite integral is the integration from -1 up to 2 of x squared minus 5x with respect to x. This is easy. When you integrate x squared, it is x cubed over 3. And then minus, we use the power rule. Integration of 5x is 5x squared over 2. And we have to evaluate this between -1 and 2. So if we use the fundamental theorem to evaluate that, we plug in the upper limit, we subtract and plug in lower limit. So if you plug in upper limit, if you plug in 2, 2 cubed is 8 over 3. Okay, 8 over 3 minus, if you plug in 2, 2 squared is 4, 4 times 5 is 20, 20 divided by 2 is a 10, minus, subtract and plug in lower limit. If I plug in -1, that will be -1 cubed, which is -1 divided by 3. And then if I plug in -1 again, -1 squared is 1, 1 times 5 is 5 over 2, so minus 5 over 2. Now the first part is 8 third minus 10. Okay, 8 third minus 10 is a 22 third. Negative 22 third. Negative 22 third. And then minus, because these two are also minus, so negative times the negative quantity will be positive. And then 1/3 plus 5/2 is 17/6, like that. And if we combine these two fractions, you should get -9 over 2. So that is the value of the definite integral, and we evaluate this using the fundamental theorem of calculus. Okay, now we are on the last example now. We have to evaluate this integral using the fundamental theorem of calculus again, which is again very simple. So let's write it down. Here we want to evaluate the integral from 0 up to pi over 2 of 4 times sine x with respect to x. So 4 is a constant as it is, and then the derivative of sine x is negative cosine x. So if you multiply by negative cosine x there, that becomes -4 cosine x. And we have to evaluate this between 0 and pi over 2. Evaluate it between 0 and pi over 2. So if you plug in pi over 2, it becomes -4 cosine pi over 2. We subtract and plug in lower limit, subtract and plug in 0. So we have a -4 cosine 0. And what we know is cosine pi over 2 is a 0. So it will be -4 times 0. And then negative and negative is positive. 4 times cosine 0 is 1. So the first term is 0, second term is 4, which is equal to 4. So that is the value of the definite integral. And here also, we evaluated this definite integral using the fundamental theorem of calculus. So that is the last example for today. Thank you so much for watching the video. I hope this is helpful.